changing the base of a logarithm. So if I asked you to evaluate log of 10 base 3, one thing that you could do is just put that straight into your calculator. Your calculator has got log of base 10, that's this button here, and log of base e, and many calculators now have got logs of base, base anything. So just to remind you where that is on the Casio, if you press option and then calc, and then we press F6, we get this log b base a. We click on that, and then if we type in our base 3 and then our number 10, then we can calculate the log of 10 base 3 like that. But it's possible to work out the log of 10 base 3 without using this button. You're thinking, why would I need to do that at this stage if I've got that button? Well, there are instances where we want to change the base, so that's what we're going to have a look at. Okay, so the first thing is to consider this logarithm as an index. So we should be comfortable now with changing a logarithm to an index. So log of 10 base 3 is equal to x can be rewritten as 3 to the power of x is equal to 10. Okay, now what I'm going to do, that's an equation, so I'm going to take logs of both sides. So in this I can choose whatever logs I like. In fact, let's do this twice. Let's do this once using one log base and another time using a different log base. So over here I'm going to choose log base 10. So I'm going to take log base 10 of both sides. Now I can write my little 10 down here as my base, although if we leave that out, there's kind of an assumption that that's what we mean. We need log base 10. Take log base 10 of the other side, like that. Okay, and I'm going to use my third law of logarithms here. So this power here, we can rewrite log of 3 to the x as x lots of log of 3. Now then this is quite nice in that we can write log of 10 base 10 to 1, but actually I'm going to leave it as it is because it helps us to see the rule. So if I want to solve for what x is, and that's what we've got at the top here, then I'm going to leave x here and I'm going to divide both sides of this equation through by log of base 10. Sorry, log 3 base 10. So there we go. X can be written as log of 10 over log of 3, both of those logarithms to base 10. Okay, now I can type that one in my calculator, so let's just try that now. So here we go. We can see the result that's still on the screen there from when I previously pressed it. So log base 10 is this button here. So log base 10 of 10, which as we just said is 1, and I'll divide that by log of 3 base 10, and hopefully I get exactly the same answer. Yes, I do. All right. Now then, I chose in this case to use log base 10, but I could have chosen any base. And I'm going to use a different base that we can find on our calculator, which is log to base e. So what I'm going to do is I'm going to rewrite this equation. So if you remember, I've got 3 to the x equals 10, and this time instead of taking log base 10, I'm going to take log base e. Okay, now log base e we can write in the short form of ln, so that's ln3 to the x and ln of 10, and then I'm just going to do exactly the same manipulation here in that 3 to the x, log of 3 to the x is x lots of log of 3. So I can divide both sides through by log of 3 to leave me with the natural log of 10 over the natural log of 3. Okay, you might be able to see some similarities there between what I've just found and what we found previously. And let's just pop this in our calculator just to check that we're getting the same thing. So log of natural log of 10 divided by the natural log of 3. Hopefully you're checking this at the same time, and bingo, it gives me exactly the same number. So obviously it doesn't matter which base that I choose here to take logs of both sides. I'm always going to get the same amount. Okay, and therefore you should be able to see that there's a rule. Okay, you maybe notice straight away there that the numbers that I've got here and the number that I've got here are the two logarithms that I'm taking. Okay, so our rule, and this is in our formula booklet for IB, if you want to find the log of A base B, it's the same as log of A divided by the log of B. And as we've put base C there, that can be any base at all. Okay, so let's try and use that to solve a couple of problems. First of all, how about this one? Here we've told some information, log of 3 to the base x is equal to A and log of 6 base x is B. So what we're asked to do is work out what log of 6 is base 3. Now ideally I'd like to know what this number is, not to base 3 but to base x, because that's what I've got information about. Well, if we just look back at our rule up here, the log of A base B is the log of A over the log of B. So let's just rewrite that then. Log of 6 base 3 is the same as log of 6 over log of 3. And here I can choose any base that I like. Now what is going to make sense is to choose the base that I know here. So I'll take log of base x. So log of 6 base 3 is the same as log of 6 divided by the log of 3. Log of 6 is equal to B, and the log of 3 is equal to A. So we can rewrite log of 6 base 3 in this case as B divided by A. Right, let's have a look at another example. Now this is an equation with logarithms in. And this one's quite challenging because we've got different bases here, which is not so helpful. So if we can manipulate this equation to have the same bases, then I think that's going to help us solve it. Now then, it would be useful if we had log base 9 for both of these, I think. So what I'm going to do is rewrite this logarithm here as a log base 9. So log of x base 9, the first part there, two lots of, let's rewrite this using the formula. So remind ourselves, okay, log of A base B is the log of A divided by the log of B. Okay, so log of 9 therefore, base x is the same as the log of 9 divided by the log of x. And again, I can choose whatever base that I put in here as long as it's the same. And let's choose 9, that's the thing that makes sense. And that's equal to 3. Now why is that useful? Well, first of all, you might notice here I've got log of 9 base 9, which if you think about what that is, that's just the number 1. So let's just put that in, that might make it easier for us to see. So two lots of 1 over log of x base 9 is equal to 3. So we've got an equation to solve. Now it's not immediately obvious at first glance, but actually this is a quadratic equation. Yeah, it doesn't look like one at all, does it? So let's just help our eyes see that this is a quadratic equation. What I'm going to do is I'm going to replace log of x base 9 by y. So there and there. Okay, so let's rewrite that. Y plus 2 over y is equal to 3. Now that's better. That helps our eyes sort of be able to solve that equation. It might still not be immediately obvious to you that that's a quadratic. But if we multiply everything through in this equation by y, then first of all I'll get rid of this fraction and it'll help me solve it. So times both sides of the equation by y. That's here. That means that this becomes y squared. 2 over y times y becomes 2. And on the right hand side I need to times this by y as well, so 3 lots of y. Okay, right, if I subtract 3y from both sides, I'm going to end up with y squared, let's put it there, minus 3y plus 2 is equal to 0. Okay, so there we go, it is a quadratic equation. Let's try and solve it. It will solve by factorising. Hopefully we're quite comfortable with that. So I'll go through that quickly. So we've got y is equal to 2 and y is equal to 1. Now what on earth is y? Well, y is something that we introduced here just to make it easier to solve. And y is the same as log of x base 9. So let's pop that back in. Log of x base 9 is equal to 2. Log of x base 9 is also equal to 1. So there we go. There's 2 roots to this equation. Now again, just when we're solving these logarithm equations, it's always easier to think about this in terms of an index. So log of x base 9 equals 2 can be rewritten as 9 to the power of 2 is equal to x. This one, 9 to the power of 1 is equal to x. So that means x is equal to 81 and x is equal to 9. And there we can see how it's useful to be able to change bases. I think that question, even with a calculator, would have been fairly tricky to do, perhaps even impossible. So being able to change bases of our logs is going to help us with that type of question. Okay, have a go at some questions for yourself.